Hi, this is Mrs. Moret. I'm going to be reteaching about arithmetic and geometric sequences. In order to retake this test, you need to make sure that you can do all four of these things. Determine whether a sequence is arithmetic or geometric, and then find the common difference or common ratio. Write both a recursive definition for arithmetic and geometric sequences using function notation and an appropriate domain, and then write a definition for the nth term of an arithmetic or geometric sequence, also using function notation and an appropriate domain. So here's an example of this type of one of those types of sequences. And by looking at the sequence, I can see every time that I go from one term to another, it appears to be decreasing by 10. And so that tells me, because it's changing by the same number each time, that it's an arithmetic sequence. And to find the common difference, so a common difference is a term that we use with arithmetic sequences. And you take any term in the sequence, so for example 22, and you subtract the term before it. So this sequence, this arithmetic sequence, has a common difference of -10. The next objective is to be able to then write a recursive definition for this sequence. A recursive definition always has three parts. The first part tells us what the first term is. The second part tells us what to do with the term before any term to get to the one that you're on. So for this particular sequence, the first term is 32. So that would go here. And to get to the next term, you subtract 10. So -10 would go at the end of that statement. And then the third part of writing a recursive formula is to state the domain. So if the first term is f of 1, then the domain is all of the n values past 1, so greater than or equal to 2. And so then after that, we're going to look at that same sequence and we're going to write the explicit or defining the nth term. So to write a definition for the nth term for this formula, there's two parts. The first is to state the equation in general. And so this equation only uses values of what's in there. So we don't refer to f of n minus 1, refer to the actual value. So since this starts at 32, that's part of the equation. And then it's decreasing by 10 on each step. And then our domain, if this is the first term, second term, third term, fourth term, fifth term, our domain tells us where the sequence starts. It starts at the first term. So n is greater than or equal to 1. And then you just plug the number in and see if it works. So 32 minus 10 times 1 is equal to 22, and it was supposed to equal 32. So this is an example of when you would then do the parentheses minus 1 and then check. So 32 minus 10 times 1 minus 1, because I put a 1 in for n, and then that does equal 32. And so that's correct now. So the definition for the nth term in this formula, this sequence, is f of n equals 32 minus 10 times n minus 1 for n values greater than or equal to 1. we have a new sequence here, and I notice that there's some different jumps going on. And so I'm going to do some division this time to figure out, it appears to be geometric. And so as I check along here, dividing any term by the one before it, I get 0.25. And if you check all the way down the row, it's the same 0.25. So this is geometric. So it appears to be dividing, but a geometric sequence is constant multiplication. It's just that the number it's multiplying is a decimal, or you could write it as a fraction. And so it appears to be dividing, but we are going to just use the common ratio. Again, you find that common ratio by dividing any term by the term before it. So we used this formula, which means to find the common ratio, take any term in the sequence and divide it by the term before. And so when we do that in this sequence, we get 0.25. So that means that to advance in this sequence, you multiply a term by 0.25 to get to the next term. So again, we're going to write that recursive formula for this, and remembering that excuse me, there's three parts to the recursive formula. So if I say this is term 1, 2, 3, and 4, my recursive formula starts with defining the beginning term. F of 1 equals 40. The beginning term for this sequence is 40. The rest of the terms, that's why we use f of n, is equal to the term before it, f of n minus 1. And then it's tempting to say divided by 4, but instead we're going to use multiplication times 0.25. And then the last part, because there's always these three parts for recursive definitions, is to state the domain. So again, the beginning term is already defined. You have to use the equation for the rest of the terms. And so the rest of the terms starting when n is greater than or equal to 2. We use that formula to find them. Okay, so that was the recursive formula. And now we're going to look at the same sequence and generate its definition for the nth term. So again, the sequence is constant multiplication. And so repeated multiplication means that in this definition, we're going to be using an exponent, because repeated multiplication is what an exponent is. And so for our, oh, and I just noticed that this was actually H, minor detail. So our definition for the nth term is H of n equals that starting beginning term, and then it's being multiplied by 0.25 over and over and over, which is why we use an exponent. And we already stated that this was term 1, 2, 3, and 4. And so the domain is n is greater than or equal to 1. And then we're going to find this again, that once we plug that 1 in, that we're going to probably have to make an adjustment. So we plug the 1 in for the exponent, and we get 40 times 0.25 to the first. And 40 times 0.25 to the first is equal to 10, but we're saying the first term is 40. And so again, we need to put this little minus 1 and then try it again. So 40 times 0.25 to the 1 minus 1. Well, 1 minus 1 is 0. So 40 times 0.25 to the 0. 0.25 to the 0 is equal to 1. So this is really 40 times 1, which is 40. So now it works. So to define the nth term for this sequence h of n equals 40. I don't know what that is. Get rid of that. Okay, so 40 times 0.25 to the n minus 1, and for our n values that are greater than or equal to 1. Okay, so you can rewatch this video as many times as you need to until you feel like you are progressing towards standard on those 4 big ideas. Determine whether a sequence is arithmetic or geometric, then find the common difference or common ratio, write a recursive definition using function notation in an appropriate domain, and then a definition for the nth term, also with function notation and an appropriate domain.